Hello students, I hope that you are good, well and fine. In today's session, we will be seeing NCERT exercise 11.2 solutions. Okay, so first question of this exercise says show that the three lines with direction cosines 12 by 13, minus 3 by 13, minus 4 by 13, and for second line 4 by 13, 12 by 13, 3 by 13, and third line 3 by 13, minus 4 by 13, and 12 by 13. Okay, these three lines with these direction cosines are mutually perpendicular, you have to show. Okay, so what will be your approach to show that they are mutually perpendicular? Very simple, that if they are mutually perpendicular, this means you have to find out the angle between them, and that angle must be of 90 degree or pi by 2 radian. Okay, so we know the formula. So let's see. Two lines with direction cosines L1 M1 N1 and L2 M2 N2, okay, perpendicular if L1 L2 plus M1 M2 plus N1 N2 is equals to 0. From where we have arrived this? We have already discussed that. Okay, so now for the line with direction cosine these, we obtain what? According to this expression, you will have equals to 0. You will have it equals to 0. Okay, I hope it is clear to you. Okay, now so this means your lines will be perpendicular. Now for second, what with direction ratio these, you will apply the same expression, substitute these values, you will get 0, which means lines are perpendicular. Again for the leftover lines, okay, you will have these as your direction cosines, apply in this form, you will get still 0. So this means each of your line are perpendicular to each other. Okay, very simple. What you have to do is just remember this little thing, that it must be equals to 0 when you are talking about perpendicularity. Okay, I hope that it is clear to you. Now let's move to second question. Show that the line through the points 1, minus 1, 2, 3, 4, minus 2 is perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. Okay, you are given 4 points. Okay, and from these 2 points 1, minus 1, 2, 3, 4, minus 2, you have a line, and another line is passing through these 2 remaining points, and you have to show that both of these lines must be perpendicular to each other. Okay, let's see. AB line joining the points, okay, this, and CD will be the line joining these points. Clear? Now direction ratios will be very simple. The scalar, if you write this AB vector, okay, in component form, and then you find the scalar components, you will get those scalar components will be your direction ratios. Means for I hat 3 minus 1 means 2, for j hat 4 minus 1 will be 5, and for k hat minus 2 will be minus 4. So 2, 5 and minus 4 will be your direction ratios, okay, for of AB. Now the same we will be applying for CD. You will get direction ratios as 3, 2 and 4. Okay, 3, 2 and 4. Simple. Now if both of my lines are perpendicular, then you have to do what? Just very simple thing, that multiply the scalar product corresponding multiply the component with the corresponding component to the other direction ratios. Okay, for example, 2 must be multiplied with 3, 5 must be multiplied with 4, and 2 and minus 4 will be multiplied with 4, and add them. You will get, if you are getting 0, then you will have that both of my lines, AB and CD line segments or lines, will be perpendicular to each other. So let's see. 6. So you can see 6 plus 10 minus 16. This means 16 minus 16 means 0. So they are perpendicular to each other. Okay, what we have used here? We have used the just simple the what dot product. Okay, we have used what dot product. Okay, now let's move to the third one. Show that the line through these points 4, 7, 8, 2, 3, 4 is parallel to the line through the points -1, -2, 1, 1, 2, 5. Okay, very simple. What will be your first step? Quite simple. The first of all, you will have to find your component form type. So AB is a line joining from using these points, and CD will be using these 2 points. Then your direction ratios for AB will be what? 2 minus 1, 3 minus 7, and 4 minus, it means -2, -4, and -4. Okay. Now for CD, direction ratios will be what? 2, 4, and 4. Simple. Now, as you have to show that both of your lines must be parallel to each other, this means you have to show that your direction ratios must be some scalar multiple. For example, if you are having -2 here, then after applying the scalar multiple here, you must get 2. Okay, so as you can see, if you multiply with -2, you will get -1, you will get 2. Then the scalar you used, what scalar you have used here? -1. This means now you have to apply the -1 to this -4, and for this also this -4, and you will get the corresponding component. If you are getting the corresponding component, then this means that you are having 2 parallel lines. Or if you want to say, if you find out the ratios of the corresponding component, for example, -2 divided by 2, -4 divided by 4, -4 divided by 4, then you must get the same scalar as your ratio. Okay, as you can see, A1 by A2 must be same as B1 by B2 must be same as C1 by C2. So in all the cases you will get -1. This means this is happening. This means your AB line from the points 4, 7, 8, 2, 3, 4 is parallel to the another line CD going from the points -1, -2, 1, 1, 2, 5. Okay, simple things. Okay, let's move to next, fourth problem. Find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3, 2, 3i hat plus 2j hat minus 2k hat. Okay, here you have to find equation of the line which passes through this point 1, 2, 3 and parallel to this vector. Your line must be parallel to this vector. This means if your line is parallel to this vector, then your form will be what? Very easy. I hat plus j hat, I hat plus 2k hat plus 3j hat, 3k hat, and then plus lambda times you will get. Okay, plus lambda times this vector, you will get your required equation of the line in vector form. Okay, very simple. Whenever you are given with a point or an initial point or a point from where your line is passing, okay, you will assume that, okay, as like in this form a vector which is I hat plus 2j hat plus 3k hat, where 1, 2, 3 are the components here, scalar components, and which represent the passing points. Okay, clear? Okay, now, and the given vector form for to use that, this will be your parallel vector to the line. This means this represent your B vector. Okay, and whenever you have such conditions, such cases, then always use this form to get your line equation, that initial or the position vector through A plus your lambda times B vector. Okay. Now, fifth problem, find the equation of the line in vector and in Cartesian form that passes through the point with position vector 2i hat minus j hat plus 4k hat and is in the direction, so this. Okay, very simple. So you are already given your position vector 2i hat minus j hat plus 4k hat and the direction which the line have to follow, this direction. Okay, simple. So let's see, very easy. So we'll be using the same conditions, as A will be your position vector, or this, if you want to know, the scalar components 2, minus 1 and 4 represent the point where your line is passing from. Yes, so 2, 1, 4. Okay. Now first of all, let's see the vector form. As this will be your A and this will be your B. Now you know, whenever you are given your position vector and the vector which is parallel to the line, you will have to use this form, R vector R is equals to the vector A plus lambda times vector B, where lambda is any scalar. Okay. Now this will be your required form in vector form. Okay. Now to find out what the Cartesian form, combine the I hat, pair the I hat things, pair the j hat things and pair the k hat things. Okay, what do I mean by that? It's very simple. First of all, distribute this lambda to each component here, I, j hat, k hat, and then rewrite it as like this by grouping, making pairs like lambda plus 2 I hat plus 2 lambda minus 1 j hat plus minus lambda plus 4 k hat. Then from here you can get your Cartesian form easily. What? Just write what you have to write. Very simple. That then you will have this thing. In order to get your Cartesian form, you have to eliminate your lambda, and then you will get what? X minus 2 by 1 is equals to y plus 1 by 2 is equals to lambda z4 by minus 1. Or if you want to eliminate this step, you can do also. How? That very easily you can make this Cartesian form from where, if you remember, the passing points are 2, minus 1 and 4. So as you can see, 2, minus 1 and 4. Yes, 2, minus 1 and 4. Okay, so this means you have to write what in what form? Quite simple, that you have to write x minus 2. In numerator, you first of all write x minus 2, y minus 1, as you are having minus 1 here. Okay, z minus 4. Okay, and in denominator, what you have to write is very simple, the corresponding component from this vector, v vector, 1, 2, minus 1. So as you can see, 1, 2, minus 1. Yes, without writing these, you will have your Cartesian form very efficiently and very quickly, comparatively. Okay, I hope that it is clear. Okay, otherwise you have to compare your things, like x is equals to lambda plus 2. This means x minus 2 is equals to lambda. From here you have to write like y plus 1 divided by 2. So here must be plus sign. Okay, sorry for that, the typo. So plus must be here plus sign. Now the minus lambda will be what? As you can see, z minus 4 divided by minus 1. Okay, very simple. Okay, clear? Now the sixth problem, find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5 and parallel to the line given x plus 3 by 3 is equals to y minus 4 by 5 is equals to z plus 8 by 6. So you have to find a Cartesian form of the line which passes through this point and parallel to the line given. So your line is parallel to this line given here. Okay. Now, you know that this line is passing from where? Minus 3, 4 and minus 8 point. Okay. The position vector. Okay. So, and this line, this Cartesian form given to you, this represents your line. This line follows the direction or parallel to the vector what? 3i hat, 5j hat and 6k hat. Okay. This means that this line, as it is already given that the above line or the line you have to find is also following the same same direction and also parallel to that vector which is 3i hat, 5j hat, 6k hat and passing through this point. This means you will have, if you want your equation in Cartesian form, you will have x plus 2, y minus 4, z plus 5 and in denominator you will have x plus 2 divided by 3, y minus 4 divided by 5 and z plus 5 divided by 6, as you can see. Okay, as you can see, x plus 2 divided by 3, y minus 4 divided by 5, z plus 5 divided by 6 is equals to k, some lambda, some any scalar constant. Okay, I hope that it is clear. Very simple. As you just saw, we have skipped these in between steps to get your answer directly. I hope that you understood how we get here. So let me just once again go through this problem. So it is given that line passes through the point minus 2, 4, minus 5 and parallel to this line. Okay. The direction ratios for this line are 3, 5, 6. Now what? This means that you have what? The required line is parallel to this. Okay. Now what? Now therefore its direction ratios are 3k, 5k and 6k, where k is any non-zero scalar. It is known that the equation of the line through the point with the direction ratios given by this. Yes, we all know that. This means you know x1, y1, z1 minus 2, 4, minus 4 respectively and a, b, c as 3, 5, 6. This means you will have this as your Cartesian form for your required line. Okay, I hope it is clear. Now the seventh problem. The Cartesian equation of a line is this. Write its vector form. So you have to write its vector form. Very simple, very easy to write. As you know, 5, minus 4 and 6 will be your the point from where your line is passing. Okay, the position vector of this point will be 5i hat minus 4j hat 6k hat, as you can see. Now the direction ratios of the given line are 3, 7, 2, as you can see here, 3, 7, 2. Now what? This means that the line is in the direction of this. Okay, this means you will have your form as r vector is equals to a vector plus scalar times b vector. This means a vector is your this 5i hat minus 4j hat plus 6k hat plus b vector will be 3i lambda times 3i hat plus 7j hat plus 2k hat. Okay, so this will be your required vector form equation of the line, or you can also directly write as 5i hat minus 4j hat 6k hat here plus lambda times 3i hat 7j hat plus 2k hat. Okay, you can also directly write. Okay, now eighth problem. Find the angle between the following pairs of line. Okay, so in first, very easy to find the angle. So you know the formula. So cos q, here we are taking q as our angle. So cos q, you know that this vector b vector dot product with this b vector divided by the magnitude divided by the product of the magnitude of these, and the absolute value of that. You will get your angle like what? First of all, B1 is this, B2 is this vector. Now magnitude for B1 is 7, magnitude for B2 is 3. This means now the dot product will be just 19, and this means cos Q will be 19 by 21. This means your angle will be cos inverse 19 by 21. Okay. Now for second, B1 is this, B2 is this, B1 magnitude will be root 6, B2 magnitude will be 5 root 2, dot product will be 16, cos Q will be the absolute value of the B1 dot product with B2 divided by the product of magnitude of B1 and B2. Cos Q will be 16 by root 6 multiply 5 root 2. Simplified, you will get cos Q will be 8 by 5 root 3. This means cos, just Q, your angle will be cos inverse 8 by 5 root 3. Cos inverse 8 by 5 root 3. Okay, now ninth problem. Find the angle between the pair of lines. Very simple, the same thing we have to do, but here you are given that it is your equation will be in Cartesian form. Okay, no problem. You know all the steps, all the necessary steps. So B1 will be what? 2 I hat 5 j hat minus 3 k hat, and B2 can be formed using these numbers, these scalars. Okay, so now B1 magnitude will be root 38, B2 magnitude will be just 9, dot product will be 26. Your angle Q will be the angle in between your lines. This means cos Q will be this expression given by this expression. This means cos Q will be 26 divided by 9 root 38. Q will be, your angle will be cos inverse of 26 divided by 9 root 38. Okay. Now the same steps we will be doing for second part. So B1 and B2 will be very easy to find. So B1 will be 2 I hat 2 j hat plus k hat. B2 will be 4 I hat plus j hat plus 8 k hat. Okay. Magnitude for B1 will be 3. Magnitude for B2 will be just 9. Dot product will be 80. This means your Q, if you take Q as your angle in between your lines, this means cos Q will be given by this expression. So cos Q will be 2 by 3, or Q, your angle will be cos inverse 2 by 3. Okay. Simple. Okay. I hope it is clear to you. Now, 10th problem, find the values of P so that the lines 1 minus x by 3, 7y minus 14 by 2p is equals to 7 minus z minus 3 by 2, and next line are at right angle. This means both are perpendicular to each other. Very simple to find. Whenever you have two lines perpendicular to each other, what you have to do? Very easy. That if you know, you can easily find out the direction ratios as this. This means, and for this line your direction ratios will be just nothing but this minus 3p by 7, 1 minus 5. Okay. Now whenever you have two lines and you have your their respective direction ratios, then just multiply the corresponding component to the corresponding component of the other line and add them equal to 0. If you are getting your answer as 0, then this means they are perpendicular. So for example, here, as it is already given that it must be equals to 0, this means you will have 9, this 3 minus 3 multiply with minus 3p by 7, 2p by 7 multiply with 1, 2 multiply with minus 5 must be, then this sum must be equals to 0. This means 9p by 7 plus 2p by 7 minus 10 is equals to 0. Rearrange your terms, cross multiplication, you will get p value as 70 by 11. So value of p will be 70 by 11. Now 11th problem. show that the lines x minus 5 by 7 is equals to y plus 2 by minus 5 is equals to z by 1, and x by 1 is equals to y by 2 is equals to z by 3 are perpendicular to each other. The same approach we will be using here as we just saw in the above problem. So direction ratios will be 7 minus 5 1, 1 2 and 3 respectively. Now multiply 7 with 1 plus minus 5 with 2 plus 1 with 3, and if the sum is equals to 0, then they are perpendicular to each other. Let's see. 7 minus 10 plus 3, this means 10 minus 10 will be 0. Okay, so you have your sum as equals to 0. This means both of the line given in the Cartesian form are perpendicular to each other. Okay, now 12th problem. Find the shortest distance between the line. You have to find the shortest distance. So very easy. Now, two lines given, this and this one. You know the shortest distance between the lines if your line is given in this form. Okay, given by this expression. The cross product of B1 and B2. Okay, and this cross product must be what? Then we have to use the dot product with A2 minus A1 now, then divided by the magnitude of the cross product of B1 and B2, and then apply the modulus sign. You will get your shortest distance between these two lines. So on comparing, you will have A1 as this, B1 as this, A2 as this, B2 as this. A2 minus A1 will be I hat minus 3j hat minus 2k hat. B1 cross with B2 will be given by this determinant, and this will give you minus 3i hat plus 3k hat, and the magnitude will be root of minus 3 whole square plus 3 square, which means 3 root 2. Okay, and now substitute your values here in this expression, and you will get your shortest distance, which is what? D will be minus 3 multiply with 1 plus 3 multiply with minus 2 divided by 3 root 2 and the whole modulus. Then D will be minus 9 by 3 root 2 whole modulus. This means you will have your shortest distance as 3 divided by root 3, or to rationalize the denominator, you can multiply the numerator and denominator by with root 2. Then you will get 3 root 2 divided by 2 as your shortest distance. Okay. Now 13th problem. Find the shortest distance. The same approach we will be using. Let's see. Given two lines. Okay. We know if you are given the two lines in the Cartesian form, then the shortest distance given by this, that x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. Okay. If you try to compare your things, okay, this determinant, yes, this determinant, okay, is getting dot product with this thing. Okay, forget it. You will be get confused if I make some sense out of these two. Okay, so for now we will be stick to our formula, which is related to Cartesian form only. Okay, so let's see. So you have this expression, this determinant in the numerator, and this root thing in the denominator. You will get your shortest distance between two lines. So x1 will be minus 1, y1 will be minus 1, z1 is equals to minus 1. Okay. Now a1 will be 7, b1 will be minus 6, c1 will be 1, x2 will be 3, y2 will be 5, z2 will be 7, a2 will be 1, b2 will be minus 2, c2 will be 1. This means this determinant will be 4, 6, 8, 7 minus 6, 1, 1 minus 2, 1. This means after evaluating this determinant, you will have minus 1, 1, 6. Now for this root thing, you will have your value as root 116, this, which means 2 multiply root 29. Now you know your values, apply in this form, you will get D as your minus. So here we must use the absolute sign. Okay, the absolute sign is missing. Okay, so you will get what? D must be, as you know, the distance cannot be negative, so you have to use, or you can use the modular sign, or just neglect or ignore the minus sign from here, as distance cannot be negative. Okay, so D will be 2 root 29 units. Okay, it is already written over here. Your distance will always non-negative. Okay, now 14th problem. 14th problem says find the shortest distance between the lines whose vector equations are given in this form. Okay, so very simple, you know the formula. Okay, just by compare you will get your a1 a2 b1 b2, as a1 as this, b1 as this, a2 as this, b2 as this. Now a2 minus a1 will be 3i hat plus 3j hat plus 3k hat. b1 cross b2 will be minus 9i hat plus 3j hat plus 9k hat. The magnitude for this cross product will be just what? 3 root 19, and dot this cross product, now getting dot product with a2 minus a1, you will get 9. Now substitute all of these values in this expression, you will get the shortest distance as 3 by root 19 units. Okay, now the last problem of this exercise is find the shortest distance between the line whose vector equation is given in this following manner. So you will have, this means you know your distance formula, your shortest distance between any two lines. You know a1, by comparing you will get a1 a2 a1 b1 a2 b2. Okay, clear? So as you can see, okay, I hope that it is clear to you. Okay, now what? Now as you can see what is happening. So first of all, what you have to do, you have to make your form in this, okay, in this kind of form, that your a1 plus lambda times scalar times b1, and like this form. So as you can see in originally your vector form for your lines is given in this form. This means you have to separate your things, separate your things. So in order to separate, you have to first distribute this I hat, j hat, k hat. Okay, and then you will get your some a vector plus scalar times, here scalar we are using t, times some another b1 vector. This is your a2 vector, some scalar times, here scalar we are using s, and some b2 vector. Okay, now on comparing, a1 will be this, b1 will be this, a2 will be this, b2 will be this, a2 minus a1 will be j hat minus 4k hat. The cross product for b1 and b2 will be 2i hat minus 4j hat minus 3k hat. The magnitude for the cross product will be root 29. The dot product of cross product and the a2 minus a1 will be minus 4 plus 12, which means just 8. Now substitute all the values in the our expression to get your shortest distance at 8 by root 29. Okay, the shortest distance will be 8 by root 29 units. So this is it for now. As this was the last question of this exercise, NCERT exercise 11.2. Okay, so thank you all. We will be back with more problems and more interesting things about this chapter 3. Okay, this chapter, okay, 3 dimensional geometry. Okay, again, thank you.